Hey there, Jack here from Rescan 3D. Just wanted to take a couple of minutes to talk through a project that I've been working on and off for about 6 months. The client's renovating a 50-foot boat as a retirement project, and he's fully gutting the interior, so as he rips various bits out, it'll get me into scan. And basically I'll just draw in panels in really specific spots that will get cut out with a CNC router and then fit exactly into place. This process saves him a ton of time in manually templating and cutting out panels for walls and floors and hatches and stuff like that. So he's been able to make a lot of progress over the last 6 months, and it's honestly quite impressive how quickly he's been able to move with the help of 3D scanning. So yeah, let's get to the footage. So as you can see, there's a bunch of different areas that we've been working on. The client designed this kitchen himself. I've just dropped his model into my main assembly, but I've done the wall panels, a bunch of floor panels and deck hatches, panels for inside the tanks, the shower structure, and in this video we'll be doing new handrails for the upper deck, as well as some of the sheet metal trims around the main cabin door. So the client's recently replaced that upper deck floor with a new sandwich panel, and we'll be scanning that and the stanchions at both ends to then model in a new handrail, which will be moulded in to match the existing shape of the boat. So as you can see, we're full daylight, there's no surface prep on the boat, there's no targets, the scanner's fully wireless, so there's no risk of getting tangled up in cables and that sort of thing. The scanner's performing pretty well in the full daylight. It's not 100%, but this is one situation where scanners really struggle a lot. They measure with lasers, basically. They project light, so if there's lots of ambient or direct sunlight, they often just won't be able to see anything, they won't produce an image. But this scanner does a lot better than pretty much any other one that I've used, which makes this job a lot easier than it could have been, really. Over this 3 meter length, the accuracy we'd expect would be about 0.1 of a millimeter, which is obviously wildly overkill for the application. We're putting 2 to 3 mil clearance around all the panels that we're drawing anyway. So the accuracy doesn't matter for this job, but just as a point of reference. We're also doing this all in about 3 millimeter resolution, just to speed it up a bit. So it's not particularly high detail, but there's no need for that detail in this application, especially where there's mostly smooth surfaces. So once we've finished the scan, we'll first align it to global coordinates, basically the XYZ in your CAD program. And now we're here in Solidworks, where I'll create some planes to start sketching those side panels. You can see we're creating these slices, the red lines, which are basically an outline of the scan on a specific plane, and that lets you really easily sketch around the scan geometry much more simply than otherwise. I'm using a plugin here called Trak 3D2, which is inside SolidWorks and lets you work with scans in SolidWorks, much better than SolidWorks does by default. It's a really good plugin, great value for money. It's not the most capable for scan to CAD stuff, certainly not compared to Geomagic Design X or something like that, but there's not much I can't do in this plugin with SolidWorks. And I'm finding the speed benefits of working directly inside SolidWorks outweigh the clunkiness or lack of tools that Trak 3D might have. You've just got to get a little bit more creative using the SolidWorks tools for stuff like surfacing especially. For a job like this though, it's perfect. You can see I'm basically just tracing around these red lines, which is the intersection with a scan on a plane. And then I'll create a closed shape and offset it by a few mil inwards to give it a bit of extra clearance. We changed the design a couple of times during this process, which is why you might see some of the features done in a slightly illogical manner. But we ended up with an angled outer panel, which locks into the radius cutout at the end, then a top piece, a vertical inside piece, and then a cap at the end. And as it happens, since filming this footage, we've changed the design again to make the end cap angled to line up with a body line on the inside of the boat, just make it look a bit neater. So that's pretty much it for the handrail. I sent these files off to the client, and his CNC routing people cut them straight out from the CAD files. Obviously we could do DXFs or dimension drawings if needed, but in this case it was just the CAD. There are a couple of jobs down inside the cabin as well. So we're scanning here above the fuel tank to make a drop-in hatch cover, and then we're going to do around the door frame to do some sheet metal trims. This is real-time footage, so you can see how quickly the scanner picks up the surface data. Again, we're now back in SolidWorks. We're going to draw some of these sheet metal parts. These are all going to get laser cut out of 1 mil aluminium, bent and then powder coated and siliconed in place, which should end up looking really good. Again, we're just tracing over these red lines here, which are these intersection slices. This will give us a really tight fit to the existing wall and floor. And we're notching around various parts of the door frame, and we've added a couple of returns to go back to the wall and trim those to cut out exactly to meet the wall. And then we're doing the same thing across the top of the door, but full side to side across the width of the boat, just to cover up that gap above the top of the door frame. So there you go, that's a bit of the process of turning a 3D scan into a usable 3D model for CNC routing or laser cutting. Hopefully you enjoyed that. If you've got any questions, let me know in the comments. I'd be more than happy to do more of these videos. I work on these sort of projects all the time, so if there's anything you want to see, just let me know. If you're based in Perth and need 3D scanning, mechanical design, drafting, that sort of thing, info@rescan3d.com.au. Be more than happy to help. Thank you.